Leetcode question 2296. So in my previous video, I talked about the solution using two regular lists to solve this problem. In this video, I'm going to talk about the solution using doubly linked list. So we created the list node, and then for the list node, each value should represent the character inserted into this text editor. So one node is a single text character. So let's code the text editor. So we define the cursor. So initially, this self.cursor points to the empty node. And then let's implement the add text. So basically, we want to actually add one character at a time. So to create a node. So in that case, we create a list node with this character. And then this node should be inserted after the cursor. So that's why I set to cursor.next. And then this node's previous node should just be the cursor. However, for self.cursor.next, let's say in this example, we want to insert XYZ between character C and D, where the cursor is. So in this case, we want to first disconnect C and D, and then insert character by character from this text after C, and then after we insert the last character, Z, from this text, we want to connect this node Z with this node D. So in that case, originally this node D, we can identify it by self.cursor.next, but in this line, this is already updated and override. So in that case, we need a temporary variable at the very beginning to actually store this. So basically, we are trying to store this node D. Okay, so after we are actually adding the node, after the current cursor, we should update the cursor location. So in this case, we are actually updating the cursor location. Move on to the next node. And then after insert all the characters from this input text into the text editor, we need to actually connect the last character, Z, which is also the location of the current cursor, with this node D. That's the original node to the right of the cursor before we insert this text. So in this case, self.cursor.next is just this temp. And then we also set temp.previous to be this self.cursor, since it's doubly linked list. However, there is one caveat. So we consider in this example the case, let's say the cursor starts in the initial position before insert this text, the cursor is in the middle. What about this case? So the cursor is actually at the end. So in that case, this temp should be none. But we cannot call the previous for an empty node. So in that case, we need to check. So if temp, and then set the previous node. So that's our add text. And then now let's implement delete text. So basically for delete text, we also need this temp. So basically for this case, it's just, let's say, originally we have X, Y, Z, and then this is the location of the cursor. And then we are trying to delete the X, Y, Z from this string. So in that case, we also need to track what is the node to the right of the cursor before we delete that. So that's why we want to store this value in a temp variable. And then for this self.cursor.value. And then also we have, since in the end we need to actually return how many characters we deleted, so let's just have a count. And this count is less than k. So in that case, self.cursor we move the cursor to the left, and then also increase count by 1. And then in the end, after we move, we get self.cursor. Then next, set it to temp. So basically, here, let's take this example. We move the cursor. So we move the cursor to the right location, to the exact location. Okay, let's say we want to delete X, Y, Z. So we move cursor here. So we move the cursor location from this position to this position. Now, if we want to delete, we actually need to disconnect this C from this X. So basically what we can do is we can actually connect this C, the node with the character C, to the node with character D. So in that case, we can just directly delete that. So in this example, so this C is where the self.cursor points to. We just set its next node to this node D, the original node to the right of the cursor before we start deleting the text. And then all similar, if temp.previous is just self.cursor. So that is we after point set the next node of this node C to be node D. We also need to set this C to be D's previous node. So that's what this line does. And then in the end, we just return this count, how many characters we just deleted. And then let's implement cursor left. So basically, while we are moving cursor to the left, so that is self.cursor.previous. So in that case, self.cursor is just self.cursor's previous. And then also another condition we need to check is k. We cannot delete more than k characters. So in that case, k greater than 0, and then we just decrease this k every time we delete a character. So why this is while self.cursor.previous? Let's say if the self.cursor previous is none, there is no node previous to this node. That means, okay, you cannot delete that cursor. You cannot delete that node. And then after we finish deleting the node, we also need to return the characters to the left of this cursor. Since this also needed in cursor.right, so let's just implement a method for this one. So left string self. So in this case, basically we have a result that stores the characters, and then we also have a count. So this count should be less than or equal to 10. Initially set to 0. And then we also have a current pointer. Initially, it's at the cursor location. The reason why is that we actually want to move this current pointer to the left to get the characters, to retrieve the characters from node.value. And then at the same time, we do not want to modify or update the self.cursor. So that's why we initialize another variable called current. Well, current.value current is just current.previous. And then count is, we increase this by 1, and then also this count should be less than 10. And then we just return. We also need to actually append this one. We'll append the node value to the result and then move the cursor to the left. And then in the end, we just return the the string. So here we just return self.left string. And then here for cursor right, so while self.cursor next, and then k is greater than 0. So in that case, self.cursor is just self.cursor dot next, and then k is decrease this by 1, and then return self dot left string. So this is our solution. Let's test it. Okay, so I made a mistake here. You can see that the characters are actually reversed. So here, so because actually I'm moving from, when I return the left string, I'm moving from right to the left, and then, so that's kind of why when I store the characters in this results list, is stored from the right to the left. But the actual string I want to return is actually from left, read from left to right. So in that case, I need to reverse all the elements in this results list and then create the string. So it passed the test case. And then the solution is accepted. The runtime and the memory is not as good as the previous solution using two regular lists.